Let me ask you a simple question. What is Kubernetes? Is it a container orchestrator in charge of operating a fleet of containerized applications, as it's written on the official webpage for Kubernetes? Maybe it is. Is it maybe a cluster operating system? Well, it could be that as well. How about a control plane with an API, a scheduler, a controller manager, etcd? Maybe it's those things as well. So let's try to figure it out. Let's try to answer a simple question. What is Kubernetes? The answer might be different than what you thought. To answer the question, what is Kubernetes, we're first going to take a look at the components that constitute Kubernetes clusters, and then we're going to jump into usages, what we can use it for. And those two things combined with a few other pieces of information might give us a clue what it really is. So, a Kubernetes cluster in the most simplified form consists of a control plane, worker nodes, and some external resources. Typically, there are 3 control plane nodes, there is any number of worker nodes, and external resources can be anything, but more often than not, or at least in most of the cases, it is storage and external load balancer. Those two are almost indispensable, but it could be many other things, and we're going to get to that later. Let's start with the control plane. What is it? What it consists of? What its purpose is? Control plane makes global decisions about the cluster, but actually not only about the cluster, but also beyond the cluster, but we'll get to that later. So it is brain of a Kubernetes cluster. That's what makes all the decisions, or to be more precise, that's where all the decisions are made. Inside the control plane, we have different components. To begin with, there is the API server. That is the front end for Kubernetes. That's how we access Kubernetes. That's how we query the resources in Kubernetes. That's how we apply the resources, and so on and so forth. That's how we talk to it, and we do it through a REST interface. Further on, we have a scheduler. Scheduler is in charge of watching for resource capacity and assigning workloads to nodes. If those workloads are running inside the nodes, but that might not be the case. But when it is the case, scheduler is the one who figures out, hey, this is where that should be running, and this should go there, and so on and so forth. It is assigning the tasks to different worker nodes. And scheduler, just like anything else in Kubernetes, is listening to the API to find out when there is something to do. And it is also controlling stuff in nodes, but we're getting to that later. Next, we have the controller manager. Controller manager is making sure that the shared state is operating as expecting. It is overseeing different controllers, and controllers are where the action is happening. Controllers are in the worker nodes, and we're going to explore them later. Or to be more precise, not all controllers are on the worker nodes. Some are not, because it depends whether it's baked into Kubernetes or are controllers that we install separately. But that's a story for a while later. Now let's move into the last actually important component in the control plane, and that's key value store. It is distributed, so that data is always available no matter what happens to control plane nodes. It contains the state of the cluster. That's the database of the cluster in a way. And typically it is etcd, but it doesn't have to be. It could be something else as well, but etcd is what comes by default. Now that we explored very briefly what control plane is, let's switch into worker nodes. If control plane is the brains, then worker nodes are where the action is happening. Now, what I'm going to say that constitute worker nodes does not really have to be the case in all Kubernetes clusters, because they can differ from each other, and not necessarily all of them are even running containers or pods. To begin with, we have kubelet. Kubelet is tracking the state of pods, or at least those pods running on the same node where kubelet is. It is ensuring that all the containers in a pod are running. That's its primary purpose. Beside it, we have kubeproxy, which maintains network rules. Its job is to figure out how all those containers can communicate with each other. Then we have container runtime, which, as the name suggests, is responsible for running containers themselves. And that container runtime could be containerd, it could have been Docker in the past, not anymore, it's deprecated, it could be runc or almost anything else. As long as it can run containers and kubelet can talk to it through a specific API, it is fine. And then we have containers themselves. That's where our applications are, that's where processes are running. It is a package of software that contains all the necessary elements required to run processes or our applications. Now, we cannot run containers directly in Kubernetes. We run containers packaged or grouped into pods. So a pod is a group of containers. Most of the time, a pod contains a single container plus sidecars. That does not have to be always the case. You can run multiple containers, but more often than not, one container plus 0 or 1 or 2 or any number of sidecars that are in charge of performing additional functions. Like Service Mesh, for example, would add a sidecar that would enhance networking capabilities and so on and so forth. Next, we have controllers. They're potentially the most interesting or one of the most interesting aspects of Kubernetes, which many people are not familiar with, at least not in the detail they should be. So what is a controller? A controller is in charge of managing at least one type of resource. So when we create a deployment, there is a controller in charge of creating and managing deployments. But that deployment, managed by its own controller, can create and does create replica sets which are managed by a different controller, and replica set can create a pod which is managed by yet another controller. So controllers are in charge of managing specific type of resources. It could be most of the time one resource, but there could be many others. And we have different types of controllers apart from deployments and replica sets and pods, which I already mentioned. We have a controller for services, which are in charge of networking. We have ingress controller, which is in charge of incoming traffic, and the external load balancers, and so on and so forth. So a controller manages one or more types of resources. And controllers have something called control loop. They're constantly monitoring the state of a resource and making sure that that state is correct, that let's call it actual state, is the same as what is the desired state. And in the context of Kubernetes, the desired state is what we told kubeAPI should be the state of some resource. Now, some controllers are baked into Kubernetes: node controller, endpoint controller, deployment, stateful set, replica set, pod, and so on and so forth. They're all baked into Kubernetes. But then others are added either by the provider that creates Kubernetes distribution or by ourselves. That could be Knative or KubeVirt or Crossplane or Argo CD and so on and so forth. If you used any of those or potentially almost any other type of application, then you're using or installing additional controllers inside your Kubernetes clusters. And those controllers can be managing other controllers or other, to be more precise, other resources inside the same cluster, or controllers could be managing external resources. A good example could be external load balancer. When we use ingress controller, then ingress controller might be creating external load balancer, or some other controller might be creating and managing storage, or some third controller or a set of controllers might be managing resources in AWS or in Azure or in Google Cloud or in VMware. So controllers manage resources, and those resources might or might not be inside the same Kubernetes cluster or in Kubernetes in general. Now, controllers themselves are also containers. Controllers are applications in a way that are running inside pods which are having containers with the processes that are doing the whole control loop. So they are essentially applications that just happen to be talking directly to Kubernetes API or Kube API and that have to follow specific rules. But if you ignore the fact that they're talking with the API and follow specific rules, they're applications in a way, but Kubernetes native or Kubernetes specific applications. Now that we went briefly through different components that constitute Kubernetes clusters and what each of those components is in charge of, we are still not much closer, or we're just slightly closer to the answer, what is Kubernetes? So let's go through different use case scenarios. And let's start with the most common use case. How do we manage applications in Kubernetes clusters? Remember, this is inside Kubernetes clusters. So when we want to run our applications in a Kubernetes cluster, we need a cluster, and then we instruct that cluster to Kube API saying something like, hey, I would like to have a deployment. Deployment is a special resource that is baked into Kubernetes. And that deployment has almost a singular purpose, and its purpose is to create replica sets, which is yet another type of Kubernetes resource. And replica sets are also not our application. Replica sets are in charge of making sure that the specific number of replicas of our application are running. And those replicas are effectively pods. So replica set creates pods, whichever number of pods we want to have, 1, 2, 3. And inside those pods, we have containers. Containers are where the application is truly running. That's something physical. Everything else is just constructs, right? So containers are running typically one process each. And those processes are our applications or something else. Now, what happens when we want to deploy, let's say, a new release of our application? So what we do, and this will probably explain why do we have so many resources until we get to our applications. Anyways, if we want to deploy a new release, we would instruct deployment to change the tag of the image of our application. And that image is effectively container image, and container is where our application is running. So remember, deployment is in charge of creating replica sets. So deployment creates a second replica set. And even though in this hypothetical scenario, our goal is to have 3 replicas of our application, that second replica set will be set by the deployment to have 1 replica of our application, because we want to do, in this imaginary scenario, rolling updates. So replica set creates 1 pod. And then when the pod is healthy, deployment continues the process and changes the number of replicas of the first replica set to 2. And then it continues. It changes the number of replica of the second replica set to 2, and the first replica set to 1, and then the second replica set to 3, and the first replica set to 0. And that's how we have our application deployed, the second release of our application deployed. And that's why we have so many resources, 3 resources or 4 resources, until we get to the application itself. Each resource, and this is now important, this is the reason why I'm explaining all this, each resource in Kubernetes, or resource type or resource controller to be more precise, is in charge of very specific set of tasks. And now you might say, excellent, so that makes perfect sense. Kubernetes is a platform of sorts that help us run our applications as containers inside of a group of nodes. And you would be absolutely right until we realize that there is more than containers. So let's talk about infrastructure, how Kubernetes manages infrastructure as well. So let's start from the beginning. We have a cluster, and in that cluster we have a number of pods of one of our applications. And then we have a second group of pods, let's say 1 pod of a second application, application B. Now those 2 applications running in containers spread across different nodes need to communicate with each other somehow. And to do that, we have yet another controller, yet another resource, or yet another resource definition called service. With services, we are enabling and helping Kubernetes understand how all the pods should communicate with each other. So far, it's still all about containers and communication between containers in a cluster. But what happens when we want to access those applications from outside? So not the communication within a cluster, but from outside. When I want to access an application running in a Kubernetes cluster, well, we create ingress. And that's where it becomes interesting. And the whole story, how Kubernetes is all about containers, starts to fall apart, or at least starts sounding like not only about containers, because ingress creates external load balancer. And to do that, it might need to speak with AWS or Azure or Google or VMware, and it needs to manage resources outside of the cluster itself. Another example would be persistent volume. Persistent volume in Kubernetes allows us to attach external drives to containers, or to be more precise, to nodes, and through nodes to containers, but let's say directly to containers. And that is also Kubernetes managing resources outside of the cluster itself. And that could be anything. It could be NFS, it could be ELB, it could be any number of technologies that allow us to manage persistent volumes, or to be more precise, external drives that are not inside the cluster itself. So it is not only about containers, but it is also about external resources and Kubernetes managing those resources directly or indirectly. Now you might say, hey, but those external resources so far, those that you explained, are all somehow related to containers. They're all auxiliary to containers, and you would be right, yes. Okay, so let's say that so far it's still all about containers and auxiliary resources that might be outside the cluster but are still in charge of helping those containers do whatever they need to do. So let's change the subject. Let's switch into virtual machines, for example. Assuming that we configure the Kubernetes to do that, we can send a request to its API and say, hey, I would like to have a virtual machine. And Kubernetes will create a virtual machine for you. We could use KubeVirt or quite a few other technologies to do that. And what matters here in this story is that Kubernetes ultimately did not create a container that is inside of a pod managed by replica set or a deployment. No. If we request a VM and we have set up our cluster properly, we get a virtual machine without containers. Actually, to be more precise, some virtual machines would be running inside of containers, but others would be running outside containers directly on the nodes of the cluster. And we can combine that with containers themselves. We can still create in that same cluster, assuming that we configured it correctly, deployments which will create replica sets, which will create pods, and those pods will run containers. And we might have ingresses redirecting traffic from outside that cluster to those pods or to those virtual machines. So we can have a cluster only for virtual machines or only for containers, or we can combine both. So is it still only about containers? What if we have a cluster, a Kubernetes cluster that is not running containers at all, but only virtual machines? The whole definition that Kubernetes is all about managing containers falls apart. It's more than containers. We already saw through external load balancers and storage that it is about external resources, but now we're getting to the point of being external resources that might not be related even to containers. But now you might say, hey, it is still about stuff running inside a Kubernetes cluster, and that stuff might be containers or might be virtual machines or something else, but we can define Kubernetes as managing stuff inside those Kubernetes clusters, but that would be wrong because I already mentioned storage is outside of those clusters and the external load balancers are outside of those clusters, but are somehow related to the clusters. Now, let's go wild and talk about Kubernetes managing external resources. Resources that have nothing to do with what is happening in the cluster itself, but the cluster is managing those resources. So let's talk about managing external resources. let's stick with our example of virtual machines and say, hey, Kubernetes cluster, give me a virtual machine. But unlike in the previous example, that Kubernetes cluster, depending on how it is configured, or to be more precise, which controllers are running inside of that Kubernetes cluster, might actually say, hey, I'm not going to do anything inside myself. I'm going to go to some API and request from that API for a virtual machine to be created and use that API to manage the state of that virtual machine and do everything that needs to be done with that virtual machine. And that API can be almost anything. It could be AWS, it could be Google, it could be Azure, it could be Alibaba, VMware. As long as there is API, theoretically at least, Kubernetes can use it to manage resources that have no relation with the cluster where Kubernetes is running. Even though that cluster needs to manage the state of that resource, the resource itself could be completely outside. Or we could send another request to Kubernetes cluster and say, hey, give me a database. And now you might be thinking, hey, is that database going to be running inside that Kubernetes cluster? And that could just as well be the case. But it could be that that database is completely outside that cluster, and then Kubernetes would go to API behind that database and say, create the database and manage that database, and it would be watching that through that API for that database, and so on and so forth. Or we could send a request to Kubernetes cluster and say, hey, you know what? Create a second Kubernetes cluster, a new Kubernetes cluster with worker nodes and control planes and networking and this and that. Create a bunch of resources. And again, if there is a controller in that cluster that knows how to do that, then we would get a second Kubernetes cluster, a new Kubernetes cluster managed by the first Kubernetes cluster, and all the resources that are related to that Kubernetes cluster, and so on and so forth. So let's go back to our original question. What is Kubernetes? Is Kubernetes, and I'm quoting now the official statement on kubernetes.io, a container orchestrator in charge of operating a fleet of containerized applications? Well, yes, it is, if that's what you do, but it can be many other things, because it might be running containers and managing containers together with a bunch of other stuff, or we might have a Kubernetes cluster that is not even managing containers. What Kubernetes does truly depends on the controllers running inside that Kubernetes cluster. And those controllers could be virtually anything. They can be managing your GitHub repositories. They can be managing sending Slack messages. They can be sending emails. They can be managing virtual machines. They can be managing databases. Those controllers can do whatever those who authored those controllers hoped or made them do. So Kubernetes cluster might be managing only containers, and that's the case for many of us. But it might also manage containers and infrastructure, or it could manage only infrastructure. It could be used to run virtual machines, or it can manage something completely different. So Kubernetes is not about containers, or to be more precise, it is not only about containers. Containers are just a beachhead. That's how it all started, but it was designed almost from the very beginning to be able to manage anything because it is highly extensible. So it started with containers, and today Kubernetes is much, much more. Early on, it was extended to manage storage. And then it was extended to manage external load balancers through Ingress, and to manage nodes through Cluster Autoscaler. Soon after it was born, it already started managing resources outside itself. And today, it can be anything. There is a lot of projects that you can, or a lot of controllers you can put inside your Kubernetes cluster to manage virtually anything. So it is not only about containers, it is about controllers and API and control loops. Those three components are the most important aspects of Kubernetes. Controllers allow us to define what Kubernetes will do. API allow us to control all that, to query, to communicate with Kubernetes, and control loops are in charge of constantly monitoring states and making sure that those resources managed by Kubernetes are in the correct state. So what is Kubernetes? Well, probably the closest description would be saying that Kubernetes is a control plane for managing whichever resources we might need to manage. It is not only about containers.